At the beginning of man's entry into space, it was uncertain how we would react to spaceflight. We also did not know if we could survive the weightlessness or even if we could work in space. The human body is a very complex piece of machinery which relies on several subsystems to perform its functions. The human body is affected to some degree by spaceflight. The most dramatic change occurs immediately after we become weightless. On Earth, gravity pulls our body fluids towards our feet, legs, and abdomen. However, when we enter space, the fluid in our body is no longer pulled down towards our feet, but shifts up to our chest and head. And that changes the way we look. Our faces get puffy and our legs become skinny. After some time, the astronauts adapt somewhat to this fluid shift. However, their bodies remain in this altered state until they're back on Earth. It does not affect the everyday activities that an astronaut must achieve. One of the tasks of the Space Shuttle missions was to study the human heart and the way it functions in space. The human cardiovascular system works well in gravity. No matter whether we're standing or lying, we always have sufficient blood supply to the brain and other vital organs. But when we go into space and take our hearts out of their normal environment, some strange things happen. The upward shift of fluid in the body tricks the heart and its sensors into believing that there's an increased blood supply. So the heart tries to compensate. First, the muscle structure of the heart compensates by stretching so that the heart can hold more blood. When this happens, other body systems tell the kidneys to eliminate what appears to be excess fluid. When the astronaut returns to Earth from space, gravity pulls much of the blood back to the legs. Now there's not enough blood to go round, and in some people there is a feeling of lightheadedness until the body manufactures more blood. Before departing Earth, astronaut Drew Gaffney had a catheter inserted into his heart through a vein in his arm. During the first few hours of flight, when the fluid shifts occur, they were able to measure the central venous pressure near Drew's heart. The experiment showed that he experienced a much more rapid fall in central venous blood pressure than was predicted. For Earthbound people, this experiment may help fight disease. The International Space Station might be a technological marvel, but it doesn't offer the comforts of home. Because this is a concentrated universe where living is anything but easy. Space is limited, putting great pressure on the astronaut's body and mind. Muscles waste, and the atmosphere is claustrophobic. When manned deep space missions become a reality, it's only going to get worse. And scientists are looking to the animal kingdom for answers, specifically tracking down the mechanism that allows them to hibernate, an ideal condition for astronauts travelling for years through space. At the University of Pavia in Italy, a research team is conducting hibernation experiments on behalf of the European Space Agency. Professor Bigioguerra and his colleagues have been able to create a hibernation-like state in cell cultures using a synthetic molecule called daedal, which has opium-like properties. In a nutshell, the team have found how this molecule reduces the energy consumed by the cell and basically puts it to sleep. But this may only be the beginning. Researchers at the University of Verona have been testing daedal on non-hibernating animals, starting with rats. The rodent is injected with daedal and its subsequent behaviour compared to that of a non-treated animal. Sensors track its heartbeat and brain activity because hibernation in animals is characterized by huge drops in heart rate, body temperature, and metabolism. Its detractors say human hibernation is sheer folly, but its supporters counter that long ago it's believed man's forebearers used to sleep through the long, cold winters. Using some spectacular footage from the Voyager craft 1 and 2, we can take a fresh look at the planet Jupiter. The Voyager's closeness to the planet enabled scientists to gain a far better view of this planet than was available from Earth-based telescopes. As Voyager passed Jupiter, it discovered a thin ring around the planet. What is its composition? We know there are 16 moons. Are there more? Several of the satellites are composed partially of water ice. One is violently volcanic. How did these bodies form, and what is their history? What can this giant planet tell us about the history of our solar system? Galileo was designed to spend an extended period of time in the Jovian System. The spacecraft would release a probe to fly its own trajectory to Jupiter. The orbiter was then targeted to its first encounter, Io, a moon known to have very active volcanoes. Then, the orbiter pointed its relay antennae toward the probe, which begins its descent into Jupiter's atmosphere. Once there, it investigated the composition, temperatures and pressures at varying levels and sent data back to the orbiter, which then retransmitted the information back to Earth. The orbiter looped through the Jovian System, measuring and observing the giant magnetic field and plasma, as well as the intense radiation that surrounds Jupiter, while performing closer studies of the moons. The combination of closer encounters and advanced instrument technologies gave Galileo much better definition of surfaces than ever before. Based on analysis of the Voyager data, the Galileo spacecraft was much improved for the task of examining Jupiter. In particular, Galileo had an entirely new device for mapping in infrared. It is called a near-infrared mapping spectrometer, which is rather like a Landsat device giving us images of many different spectral bands. The scientists on the Galileo project used these images to map composition on the surfaces of Jupiter and her satellites, including the characteristics of Jovian clouds, and to find out where there is ice and other geographic features on the planet's surface. En route to Jupiter, Galileo picked up energy by utilizing gravity assists while traveling once by Venus and twice by Earth. In addition to the bonus of studying these two planets and Earth's moon, Galileo did flybys of 1 or 2 asteroids never before closely observed. Then Galileo rendezvoused with Jupiter and its moons. This unique trajectory allowed Galileo to reach its ultimate goal, returning a bonanza of scientific information and knowledge from the Jupiter system. Scientists at the University of Leicester's Space Research Centre are using technologies developed for space research for much more practical biological and medical use. Their work on the 2 areas of cancer and poisoning has huge global significance, as survival rates are significantly improved if caught early enough. Though based in the Midlands in the UK, the Space Research Centre has collaborative partners from all over the world. The future for the Space Research Centre looks healthy. Its scientists will continue to work with their global partners on innovative medical advancements and are confident that the next 40 years of space travel will be as wondrous for mankind as the last. A European payload called SPAS, or Shuttle Pallet Satellite, provided these magnificent views. It's a unique reusable space platform built by a West German aerospace company. In addition to having film and TV cameras mounted on SPAS, 10 experiments belonging to the West German government, the European Space Agency and NASA were on the platform. The test for SPAS was to prove the satellite's design validity and that experiments could be operated successfully while SPAS was free flying. NASA wanted to show that the remote manipulator system could handle the 2.5-ton payload. The orbiter's ability to station keep with SPAS was also demonstrated. At this point, they are 1,000 feet apart. Here, SPAS and the shuttle are 200 feet apart. Thrusters on board the shuttle were fired to record the effect on SPAS. Finally, SPAS is rebirthed for return to Earth. The shuttle crew also deployed 2 communication satellites, a Canadian satellite for pay TV operations and an Indonesian satellite to help with telecommunication services to the island's many remote locations. Shuttle Flight 7 was to be the first shuttle flight to touch down at the Kennedy Space Centre, but bad weather conditions did not allow it. Challenger landed instead at Edwards Air Force Base in California, the pre-designated alternate landing site. During the period of communications blackout, usually lasting about 15 minutes, temperatures on the vehicle's surface reached their peak. The temperature of the red-hot glow seen through Challenger's front windows was about 2,400 degrees Fahrenheit. One astronaut described the view as being inside a furnace. $4.5 billion years ago, the planets were solidifying and undergoing a period of intense bombardment. The surface of Mars was no exception. 4 billion years ago, the surface was fractured and the planet was probably warmer and wetter. As time evolved, water filled these cracks, and the solutions may have resulted in the globules seen in the meteorite you're about to see. As the carbonate globules were growing, there was probably a presence of a microbiota. As the carbonates grew from the solutions and filled the fractures and voids, they began to entrain these organisms. We know this from the isotropic chemistry of the materials. Then, Mars went through a period of becoming colder and drier. We now know that during the period from 3.6 billion years ago up till 16 million years ago, a very large object struck the surface of Mars and knocked material from the surface, which then travelled through space for up to 16 million years until it was attracted by Earth's gravity, and about 13,000 years ago fell onto the Antarctic ice sheet, where it resided until discovered in 1996. A joint science foundation for the collection of meteorites, supported by NASA and the Smithsonian Institute, brought the sample back to the Johnson Space Centre, where it was cleaned and processed. A closer look underneath the bladed surface, created as it came through the Earth's atmosphere, notes the areas of weathering and alteration. As we look closer at the spot magnified many times, thanks to Monica Grady from the British Museum, we can detect the carbonate globules with their black and white rims. These are 250 microns, or approximately 5 times the diameter of a human hair, and point to the fact that billions of years ago, life in some form did exist on Mars. The equipment used to ascertain the information on the meteorite is so sensitive that it's able only to view 1,000 molecules at a time. An infrared laser hits the sample, causing it to heat up and evaporate. This produces a plume of gas cloud. Then the ultraviolet laser excites some of the molecules that can absorb it, producing ions which are picked up by the detector. The process is repeated to produce a map of the sample. By detecting the arrival time of the ions, the weight of the molecule is measured, convincing scientists of the first organic molecules from Mars. This is Baikal Space Centre in Kazakhstan. American millionaire Dennis Tito and 2 Russian cosmonauts are shown here arriving at the Space Centre. Tito, dubbed the first space tourist, and cosmonauts Talgat Musabayev and Yuri Baturin blasted off to the International Space Station in April 2001. The 3 men arrived at the Baikal Space Centre as final preparations got underway ahead of the launch. Tito, 60, a wealthy space buff, is believed to have paid Russia about $20 million for the trip. NASA had expressed safety concerns about Tito's flight, saying the Californian was not adequately trained and might prove a distraction to the crew. But a deal was reached, allowing Tito to fly into the International Space Station. The deal would essentially mean neither Tito nor his family would sue NASA if anything went wrong, and it would also require he paid for anything he broke, according to sources close to the negotiations. Tito had originally planned to travel to Russia's Mir space station, but the government was forced to dump the first Russian space station due to lack of funds. Not wanting to lose the $20 million that Tito was paying, Russian space officials offered him a spot on a 10-day cargo run to the International Space Station. Although the flight went very smoothly, reception at the ISS was a little cooler than usual, in part because NASA don't support the idea of space tourism. In addition to Tito, Mark Shuttleworth from South Africa has also been up in space as a tourist. The Soyuz TM rocket used to transport the crew into space was rolled out of the hangar in the early hours 2 days before it was to blast off from Baikal Cosmodrome in Kazakhstan. The rocket was to take South African Shuttleworth, Russia's Yuri Gitsenko and Italy's Robert Vittore to the International Space Station. Mark Shuttleworth became the world's second space tourist to blast off from the Baikal Cosmodrome following Tito, who flew to the ISS in May 2001. The internet multimillionaire had also reportedly paid close to $20 million for a ticket into space. Shuttleworth was not just a tourist, he also carried out a scientific program. And according to the head of the Baikal Space Centre, if a man is willing to pay so much money that will support the space program, why not take him? Shuttleworth spent 8 days at the space station alongside Russia's Yuri Gitsenko and Italy's Roberto Vittore. Vittore, who was selected for the flight to the ISS by the European Space Agency, became the first Italian to fly into space aboard a Russian rocket. Baikal Space Centre, once the hub of Russian space endeavours, has changed over the last few years from a very secret military-run establishment to an almost completely civilian-run facility. The military side of the operations is less than 10%. However, appearances aside, Baikal is the busiest spaceport in the world. After the Columbia disaster, they provided the only support rockets for the International Space Station.